In this lecture, we are going to see sample paper 6. So in previous lecture, we have discussed sample paper 5. I think I need to explain 4 marks question from sample paper 4. If time permits, I'll do it. Okay. So I'll come into sample paper 6. First question, section A, 2 marks question. The table below shows the power rating of some electrical appliances. There is electric iron, electrical kettle, immersion water, and cooker with the power ratings. How much current is required by the cooker at 230 volt? So they are asking how much current. So I value is equal to question mark is required by the cooker at 230 volt. So voltage V value is equal to 230 volt. Cooker they are asking. So while coming to the cooker, they have given value 8 kilowatt. 8 kilowatt. Watt is SI unit for power. So P is equal to 8 kilowatt. This can be written as 8 into 1000, which is nothing but 8000 watt. Next, we need to find I value. We know formula. Power P is equal to V into I. From this, I is equal to P by V. Power rating is 230 upon, power rating is 8000 upon V value 230. 0 gets cancelled. 800 by 23. Right, if you see 800 upon 23, which is nothing but 34.7. So we got I value as 34.7 amp. Next question. What is the resistance of electric immersion water heater working on 240 volt main? Now you see they have given that voltage is equal to 240 volt and they are asking about immersion water heater, immersion heater. So immersion heater power P is equal to 3 kilowatt. 3 kilowatt means 3000 watt. Now what they are asking R value. R is equal to question mark. Now we should have some formula which will be giving relation among V, P and R, and we have formula P is equal to V square by R. I think so you know how we got this P is equal to V square by R. In last lecture also I have discussed this. From this R value we have to find R is equal to V square by P. So V value is 240 here they have given. So 240 multiplied with 240 by power rating is 3000. 0 gets cancelled. 24 multiplied with 24. 576 by 30. 576 by 30 is equal to 19.2. So now R is equal to 19.2 ohm. So while coming to the answer, same answer we got here. I is equal to, so what we got here, 34.7. So you can write 34.7 or you can round off. You can make it as 35. And R value is 19.2. Here R value we got as 19.2. So like that we need to answer that. Second question. The position of 3 elements X, Y, Z in the periodic table is shown below. Okay, X, Y, Z is there. Which type of ion, cation or anion, will be found by element X? While coming to element X, so it is in group 1. Group 1 means its valency is 1. Always that element will be losing electron. So if element is losing electron, it is metal. So for example, sodium, let us consider, it is losing electron. After losing electron, it is becoming plus. So while coming to Na plus, whether it is, basically it is ion, whether it is cation or anion, if they ask, quite simple. Try to remember, always positive ions will be moving towards negative terminal. Negative terminal we are calling it as cathode. So ion which is moving towards cathode is known as cation. So answer is cat ion is formed. Number 2, between elements Y and Z. So here Y and Z, which has atom of comparatively larger size. We have studied trends in modern periodic table, where if you are moving from left to right, while coming to the atomic size or atomic radius, it will be decreased because of attraction. So which atom, which has the atom of comparatively larger size? Y will be larger. Answer Y. So answer, if you see, it forms cation. Cation is the answer, and element Y has comparatively larger size. Like that, we need to write the answer. Next, question number 6. From the diagram given below, so there is a diagram with coil, north magnet which is near the coil, and galvanometer which is showing 0. What will be the direction of current flowing through the coil when magnet is dropped in? So magnet is dropped in means magnet is moving like this. When magnet is moving like this, what happens? Automatically that galvanometer will be deflecting in this direction. So first of all, galvanometer will be showing 0. When magnet is moving towards the coil, automatically galvanometer will deflect like this. So it will be showing like this. So current is like this. Either you can draw diagram, or current is like this. You can name it as anti-clockwise. So simple. Magnet is moving in this direction. Galvanometer will show this magnet direction, this only. So the current will be like this. So which is anti-clockwise. So answer is anti-clockwise. Number 2. State the phenomena on which observation is made. I told you many times in the previous lectures also. Whenever you have coil and a magnet, then galvanometer, you have to write it as electromagnetic induction. So there is internal choice question. You have been provided with a solenoid AB. Okay. What is the polarity at end A? You see, it is like this. So whenever battery is connected, many times we have discussed, if you take a solenoid, if it is connected in textbook also you can observe, if this is positive or negative, if this is negative, near negative will be getting north pole, near positive will be getting south pole. Here also we have negative. So current will be passing like this. When current is passing like this, magnetic field is produced, and here near negative terminal, north pole is generated, near positive terminal, south pole is generated. Give one advantage of an electromagnet over permanent magnet. Electromagnet will have greater magnetic field, strong magnetic field, and it will not lose magnetic field. So we can control that how amount of magnetic field also. But while coming to permanent magnet, amount of magnetic field is fixed. So that is the advantage. And if you see the answer here, some wrong is given. So first of all, the first answer is anti-clockwise direction, and the observation made is electromagnetic induction EMI. And when we see through NDA, current is in clockwise direction, hence the NDA has south polarity. So they are talking like, if you are observing like this, so what is the polarity at the end A? So if you are seeing like this, magnetic field will be in circular shape, so that they are talking like end has south polarity, but no need to get confused. So you can follow this one. This is correct, but that one is wrong. And give an advantage over electromagnetic over permanent magnet, they are asking. So an advantage of an electromagnet over a permanent magnet is that electromagnet can produce strong magnetic field. So because of strong magnetic field, we are using electromagnets frequently, not permanent magnets. Then section B, first question. Give reason for the following based on household circuits and appliances. Okay, number 1. Tungsten is used almost exclusively for filament of electric lamp. Why? Because tungsten has high melting point, high boiling point, and it has high resistance. So the tungsten is used in electric lamp. Number 2. The conductors of electric heating device such as bread toaster and electric iron are made up of alloys rather than pure metal. Yes, if you see electrical heating devices, it is like a toasters and electric irons made up of alloys. Why? Because many times we have discussed, while coming to alloys, for alloy resistance will be greater, amount of current passing will be less, and heat energy will be greater. It produces more amount of heat energy. So that only for electrical heating devices we are using alloys. While coming to pure metals nothing but conductors. While coming to conductors, resistance will be least, passage of current will be high, and heat dissipation will be less. Number 3, the series arrangement is not used for domestic circuits. Why? Because in series, for example, if fan is connected, bulb here, fan is connected here, TV is connected, then one refrigerator is connected, everything is connected in series. Let us guess, if it is connected in series, to operate we have to use only one switch. So just if you want to turn on bulb, if you turn on that switch, if you put on that switch, all devices will be it will work. All devices will work. So you cannot control it. And at the same time, in series combination, voltage drops you can observe. You see, this bulb will consume some amount of voltage and remaining voltage is sent here, means voltage drop can be observed. Again, this will consume required amount of voltage and remaining voltage is sent. Here we can observe voltage drop. Like that, we can observe voltage drop near every device, every component which are connected in series. And number two, many differences you can get, many things. And well, coming to another thing is, if any device is not working, something fused off or something happened to the device, remaining devices also will stop working. So that only everything is connected in parallel for domestic circuits. Ninth, what would be the electron dot structure of molecule of sulfur is made up of 8 atoms. So 8 atoms in textbook also we got 2 shapes we can write. 1, 2, 3, 4, 5, 6, 7, 8. So sulfur atoms which are connected in circular shape. And another thing which is connected in a crown shape. Like this. 1, 2, 3, 4, 5, 6, 7, 8. Like that. So how it is connected, why it is connected is quite simple. You see, sulfur atomic number is 16. If you write electronic configuration 2, 8, 6, and this is outermost orbit. While coming to sulfur, 1, 2, 3, 4, 5, 6. Like that, 6 valence electrons we can mention. There will be another sulfur with 1, 2, 3, 4, 5, 6. You see, these 2 electrons will bond. Again, there will be another sulfur 1, 2, 3, 4, 5, 6. These 2 electrons. Next, again another sulfur 1, 2, 3, 4, 5, 6. These 2 electrons will combine. So like that, it will form a circular shape. 8 sulfur atoms will combine to form S8. S8, either circular shape or crown shape. In textbook also you can get that. That is in text question basically. Next, how many structural isomers can you draw for pentane? First of all, while coming to pentane, that is also in text question. Neath, eth, prop, but, pent. 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens we are going to get. Now, how many structural isomers we can draw? This is one structure. Second structure, remove this carbon. This carbon you remove, attach here. It becomes 1, 2, 3, 4, 5. This is second structure. Next one, remove this carbon, add it here. 1, 2, 3, 4, 5. So however you see 5 carbons will be there and it will satisfy all the valencies, but only one logic you try to remember. In a branch, at least there should be 3 carbons. This is a branch. In branch, at least there should be 3 carbons, and remaining carbons you can remove. You see, 1, 2, 3 carbons you can mention, and this carbon can be mentioned here. This carbon can be mentioned here on top. So like that, if you see, this is first structure, this is second structure, this is third structure. Total how many structural isomers you can draw means 3 structural isomers you can draw. Next, where we have number 3. Write 2 examples of microcrystalline form of carbon. Basically, this word is not there, but if you observe 9th one, you see electron dot structure of sulfur S8. So you can draw either in circular shape or you can draw in like a crown shape. And while coming to structural isomers, so this is first structure 1, 2, 3 carbons with the second one, and 1, 2, 3, 4 with the fifth carbon. So 3 you can draw. Next, while coming to microcrystalline, so you try to understand coal and lamp black are examples. Of course, it is not there in textbook, so just you have observed here now, so it will be fine. Next, internal choice. An element belongs to 14th group and 3rd period in the periodic table. Write symbol and valency of the metal. Of metal they are talking. Okay. 14th group, 3rd period. 3rd period means here hydrogen, lithium, sodium. So sodium, potassium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Argon is 18th, chlorine is 17, sulfur 16, phosphorus 15, silicon 14. So 14th group, third period element is silicon. So they are asking, of course, that is metalloid. Write the symbol. Symbol is Si. Valency. What is the valency of silicon? It is 1, 2, 3, 4. So valency of silicon is 4. So you can see element is silicon with the symbol Si and valency 4. Next question. How does atomic size of the element vary along period? Along period, how atomic size will vary? Atomic sizes will decrease if you are moving from left to right. Just they are asking how does. So you can write atomic size or atomic radius will be decreased. It will decrease. So they didn't ask you to explain. Now, if they ask you to explain, what you can write? If you are moving from left to right, atomic numbers will increase. Because of increasing in atomic number, proton count will increase. Because of proton count, nuclear charge will increase. When nuclear charge is increasing, it will pull orbits near the nucleus. That you can write. Number 3. Why Mendeleev left some places empty in the periodic table? Because he predicted, he didn't think like Newland. Newland, what he thought? He thought only 56 elements are present and no element would be discovered in future. But Mendeleev, what he guessed? He predicted that more elements might be discovered and which have same properties that of aluminium. So that only Eka aluminium, Eka boron, Eka silicon, he left gap. So he predicted. So now you see, atomic radius are moving left to right on period. Atomic radius decreases. Why? Due to increasing in nuclear charge, which will be pulling the valence electrons closer to the nucleus. Mendeleev left space empty in his periodic table for the elements which were not discovered at the time, and he predicted more elements would be discovered in future. So like that, you need to write the answer. Then while coming to question number 12, the wire in the figure below is being moved downwards through the magnetic field so as to produce induced current. You see, wire in the figure is being moved downwards. So you are moving the coil, means coil is in motion. Simply to say, force is produced on the coil through the magnetic field so as to produce induced current. You see, induced current is produced. Current is produced in which device? It is in generator. While coming to motor input is electricity and output is force. That's it, na? For motor, input is electricity. For fan, grinder, mixer, washing machine, whatever it may be, input is electricity and output is force, nothing but mechanical energy. While coming to generator, input is force, output is current, I mean electricity. So simply to say, this question they are asking regarding generator. Anyhow, generator topic is not there, so that no need to learn. Okay, what would be the effect of moving the wire at higher speed? So if you are moving this wire at the higher speed, means if you apply more force, of course, this we did not discuss. Your teachers also did not discuss about the working of generator. It is quite opposite to the motor. Okay, just to see for formality, let us see the questions. Moving the wire at the higher speed. So if you are moving wire with greater speed, means if you are giving more force, what happens? Moving the wire upwards rather than downwards. Instead of moving like this anti-clockwise, if you move clockwise, what would happen? Using strong magnets, instead of these magnets, still further strong magnets, that you can relate to motor working also. So moving the wire with higher speed, if you are applying more force, automatically what will happen? Induced current also will be greater. When force is greater, current production also will be greater. So it is opposite in motor. In motor, if current is greater, mechanical energy, that force will be greater. Na? So quite opposite. Now, you see, moving the wire upwards rather than downwards means if you are changing the force, direction of current also will be changed. That is reversed. In electromagnetic induction, we have discussed, and at the same time, we have you guys might have discussed in magnetic field and current, direction of current and magnetic field. Maxwell's rule also you can use, right hand thumb rule. Third one, using strong magnet. If you are using strong magnet, induced current also will be greater. If you are increasing magnetic field, induced current also will be greater. Like that, you can write the answer. If they ask, basically they don't ask. Now, the given figure shows DC motor model used by student study electromagnetism. That's fine. There is a magnet and coil attached to metallic strip, nothing but split rings. then it is connected to the cell. This is negative, positive. Now it is going like this, current, right? Next, the two ends of the coil are fixed to a pair of curved elastic metallic strips. The metallic strips are connected to the power supply with the rheostat. That's fine. Next, let us see the questions. State the direction of rotation of the coil when viewed from the front. Means if you are moving, like if you are observing like this is front view. Now you see current is going like this in this direction. Current is going like this and magnetic field is from north to south. Na? Current is going like this, I, and magnetic field is like this, F, or simply to say magnetic field is like this. You can apply left hand rule. So current and magnetic field, then automatically force will be in this direction, right? So if you are using current like this, magnetic field like this, force will be like this, upwards. So simply to say, coil will move like this it will move. This is the direction. So clockwise or anti-clockwise, that is obviously anti-clockwise. So like this, it is moving anti-clockwise. 3, 12, 9, like this. Number 2, the student is still testing on the feasibility of using metallic strips in the model. Why he is trying to, what he is trying to achieve? So what are those metallic strips? Which is nothing but split rings. Split rings. What is the use of split rings? Split rings are used to change the direction of current in armature. This is armature segment. This coil is rectangular coil is armature, and because of the metallic strips, because of the split rings, there will be continuous rotation in the same direction. If there is no metallic strips, if there is no split ring, let us guess, then what happens? Half turn clockwise, half turn anti-clockwise, half turn clockwise, half turn anti-clockwise, half turn clockwise, half turn anti-clockwise. Like that, it will be fluctuating like this. To achieve direction of motion in the same direction, to achieve continuous rotation in the same direction, we have to use split rings. So answer. So he is trying to achieve rotation of the coil in one direction, one particular direction. So as current in the coil reverse, for every half turn, the coil rotates in one direction. So if there is no split ring, like that, it will be fluctuating. That is the thing. Section C, 4 marks question. Right. In the beginning of 18th century, only 31 elements were known, but by 1865, the number had become more than double, 63. At present, 118 elements are known to us. Effort are still continuing to synthesize new elements. With such a large number of elements, it become very difficult to study each element and its finite compounds individual. Okay, they're simply to say they're talking about periodic table. Now, number 1, what is the basic theme of organizing the periodic table? So why we need to organize periodic table? To study, to observe, so to understand the elements clearly, to understand nature, physical properties, chemical properties, and to understand the balances, to understand atomic numbers, we have to arrange. So here answer you can see, like the basic theme of organizing in the periodic table is to simplify and systematic study of physical and chemical properties of all elements and their infinite compounds. So to study, to learn about elements. So if you have arranged, if you learn about one group, all elements which are present in the same group will be applicable. That statement is applicable. That characteristic is applicable. That physical and chemical property is applicable. So that we need to arrange. So to study, to arrange systematically, to understand the physical and chemical properties, we need to arrange. Number 2, which property of element depends on electronic configuration of the atom? So which property? That is atomic number. So chemical and many physical properties of element depend on electronic configuration of the atom. So if there is electronic configuration, then automatically that can be arranged according to valency, and that valency will be giving information about physical and chemical properties. You see, for example, if you take periodic table, this is group 1. So what are the elements present in group 1? Like hydrogen, lithium, sodium, potassium. So all elements will have valency 1. So they are so aggressive, very reactive metals. All elements will be losing 1 electron. All elements will be are forming cations. All elements are aggressive in nature. All elements are stored under kerosene. I mean, except that hydrogen, lithium, sodium, potassium stored under kerosene. If it is combining with oxygen, it will catch fire so easily. So all physical chemical properties can be applicable for all the element like that. So physical and chemical properties will be depending. Next, third one, AB. Write the number designation of group that has two elements beyond noble gas configuration. So write the number designation of a group that has two electrons beyond noble gas configuration. From the noble gas configuration, if elements are two, then what we have to write? It should be group 2, simply to say. The number designation of group that has two electrons beyond noble gas configuration will be 2. That simply to say they're talking about valency. Noble gas valency is 0. They're talking about which group will have valency 2 means second group will have valency 2. Simple. Why do elements in the same group have similar physical chemical properties? Because their valencies are same, right? This is so because presence of same valency electrons. Because of that valence electrons, elements in the same group have similar physical and chemical properties. That's it. Next, internal choice. Rewrite the following statement in correct form after correction necessary. Periods are vertical rows of elements. You see, periods are vertical rows. Basically, periods are not vertical rows. Periods are horizontal. You see, this statement can be written in two ways. This statement can be written in two ways. First way, periods are horizontal rows. So instead of vertical, you can change horizontal. Horizontal rows. Or instead of periods, you can change groups. Groups are vertical. Vertical, instead of rows, you have to write columns. So whenever you are using vertical, you have to use columns. Horizontal, rows. So here you see periods, rows they are talking. It's better to change this word vertical to horizontal. So statement A is incorrect. Periods are horizontal rows. You have to write. Next, groups have elements with consecutive atomic numbers. Groups have elements with consecutive atomic numbers. Basically, not groups, periods. Here answer is wrong. They are given like statement B is correct. No, statement B is wrong. It is incorrect. Periods have elements with consecutive. You see, first period means hydrogen number 1, helium number 2. Second period means lithium number 3, hydrogen, helium, lithium, beryllium number 4, boron 5, 6, 7, 8, 9, 10, like that. Consecutive it will be there. So like that we have to write the answer. So that's it about sample paper number 6. So in next lecture, we are going to discuss sample paper 7. So that's it in this lecture. Bye. Have a nice day.